Here is another important test application on exponential growth.
I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider a very interesting test question which is based on exponential growth and also doubling period. In the playlist, you'll find many questions. This is actually solution of the fourth question in one of our test papers. The question here is, a colony with 1920 insects is doubling every 10 days. How many insects were there 40 days ago? In how many days will there be 491520 insects, right? Now, this is very critical. 40 days ago, right? So that is kind of typical about this. Exponent is negative, right? Okay, great. I'd like you to pause the video, answer this question, and then look into my suggestions. So let's write down the equation. A colony with 1920 insects is doubling every 10 days. So we are already given something which is initial population. Let's write P0 as 1920. This is the initial population. And doubling every 10 days, so doubling time is given to us, which is 10 days. Is that clear to you? So that gives you an equation that the population is actually equal to the initial population times 2 times T over the doubling period. Correct? So that is the equation which you can follow. And we already have the values here. 1920 is the initial population, right? And doubling period is 10 days. Makes sense. So that is the equation to begin with, and we can do part A and B easily. How many insects were there 40 days ago? So that means T is equal to minus 40. Makes sense, right? T is minus 40. So when you substitute that, you should be in a position to get this answer, right? So let's do it. So we have the population, which should now be equal to what? 1920 lesser than this, right? 2, T is minus 40. Minus 40 over 10, right? Which is 1920. 2 to the power of minus 4, right? Minus 4. So that is what it is. So we can calculate this population will be 1920 times 2 to the power of minus 4 is 1 over 2 to the power of 4, right? Negative exponents. So now you can actually divide this by 2 to the power of 4, which is 16, right? And get your answer. So it is without calculator. So you could actually do this 1920 divided by 16. 16 times 1 is 16. So 32. 16 times 2, 32 and 0. So we have 120 insects, right? So we have our solution for part A, that there were 120 insects 40 days ago. Make sense? So that is the solution of part A. Now let's take up part B. Well, in case you want to learn from me, you can always send an email on the address given. This playlist has many other questions. Some of them are shown here, right? So you can explore their solutions also and try them out. It will help you to practice for your own test. So now we have done part A. Now let's get back to part B. Let me take it on a fresh page. In how many days will there be 491520? So let's look into this part. Same formula. So the formula which we used was the population is equal to initial population times, since we are talking about doubling period, T over D, right? So let's substitute the values given to us. we now want to find final population to be 491,520. Correct. Right. So we know the initial population is equals to 1920, and we also know doubling period D, which is 10 days. So now all the information is given to us. Let's put them together and simplify, right? So what we have here is 491 520 equals to the initial population of 1920 times 2 to the power of t we need to figure out, and doubling time is 10 days. So we can write this as 491 520 divided by 1920, right, equals to 2 to the power of t over 10. So we need to simplify this, right? So, and it's without calculator, otherwise it would be very simple. So you can cancel these zeros first and then divide each by continuously by 2, 4, 8, whatever, right? And then this can be, so let's divide them by 8, for example, right? So 8 times 2 is 16, and 32 means 8 times 4. And here we can divide by 8. So 8 times 6 is 48. So we get 11. 8 times 1 is 8, 35. 8 times 4 is 32. And then again 32, so we get 4. So we got 6, 1, 4, 4 and 24. We can divide by 4. 4 times, let's use a different ink. 4 times 6 is 24. And with 4, 4 times 1, 21. 4 times 5, 20. So 14. 4 times 3 is 12. 12 and 24, 6. Correct. So this number can be finally divided by 6. So let me rewrite this here. So we have 2 to the power of t over 10 equals to 1536 divided by 6. Correct. So which is 6 goes 2 times. 6 times 2 is 12. So 33, 6 times 5 is 30, and 6 times 6 is 36. Correct. Now 256 can be written as 2 to the power of something. You get the idea, right? So basically we have to write this as a power of 2, and that's the thing which is required to be done, since the test is without calculator. Get sensible, right? So how do you write 256? So 2 to the power of 10 is 1024. Half is 500 something, which is 9. So this is 8, right? So this is 2 to the power of 8. Correct. So since we have the same base, which is 2 and 2, their exponent should also be equal, right? And therefore we get t over 10 equals to 8. And that gives you the value of t as 8 times 10, and that is 80. So in 80 days, the population will be 491,520. So that's our answer. You get the idea. So in 80 days, population will be 491,520. Does that make sense? So that is how you will be actually doing it. So it's a practice. Now a couple of things to remember here, and that is, you should know the powers of 2, right? Remember that 2 to the power of 10 is 1024. Correct? You would have started from here also, multiplying by 2 this power and then getting to the result. You could have done that, right? So anyway, we have got the result here. Feel free to write your comments, share your views. In case you like and subscribe to my videos, that'd be great. You may also contact me on the email address for more information. Thank you and all the best.